Good afternoon, everyone. It's right at noon, so we'll go ahead and get started with the May 2025 Kansas Soil Health Partnership Forum. My name is Jennifer Semmelink. I'm the Executive Director of the Kansas Soil Health Alliance, who serves as the host for the forum. I want to thank everyone for joining us today. As a reminder again, for those who are unable to make it, or those that want to go back and watch this forum again, we will be posting the recordings to the Kansas Soil Health Alliance's website, our YouTube page, and then we'll also provide links to the recordings in our newsletter that we send out and on our social media pages as well. So as I've done in the past, I'm going to put up a quick 2-question survey just to get an idea of who's on our call today. With this being an open webinar, we're excited to have people who are from all aspects of ag in Kansas. So this just helps us get an idea of who's on the call and how many are Kansans. So I'm going to get that started. I'll give everybody just a minute to complete it, and then we'll be ready to go. Going to end that poll. I believe you're able to see the results. We're still working to see what all you can see while we're on this, but I'll give a brief summary because I know this does not show up on the recording. So we're 56% farmers and ranchers today, 31% education or educator or researcher, 44% agency employee. We don't have any non-governmental organization employees or reps on, although myself and Joanna are, so we'll put us in on that. 19% ag professionals, no one's from a food company professional, and then one other. And 13 of the 16 on the call, so 81% are from Kansas, and then we have a couple from out of state sharing us with us as well. So thank you everyone for completing that. And with that, I'm going to go ahead and I'll turn things over to Joanna to introduce today's speaker. But before I do, I want to remind her that everyone is muted during the presentation, but you are welcome to ask questions throughout. Just raise your hand and then we'll find time to call on you. And then we will have time for question and answer at the end as well. So with that, I'll turn it over to Joanna.
Hello, thank you. So Candy Thomas is our speaker today, and Candy J. Thomas got her start in 1994 working for the Natural Resources Conservation Service, NRCS, in Missouri. In 2013, she transferred to Kansas and retired in 2025. She currently works part-time for the Kansas Association of Conservation Districts as a soil health specialist and lives in Salina, Kansas. Her husband has a cow-calf farm in Iowa where they also follow with chickens in a high-density stocking rotation for the last 28 years. With that, Candy, we'll let you take it away.
All right, thank you. I do need to add, so my position with KACD starts on next week, the 1st of June. So it's actually June the 2nd. And Dan wanted me to be sure to let people know that I'm available, to help with producers. My previous position, we weren't really allowed to help with producers in any way, shape, or form. We were kind of limited to working with the state office. But the goal is to try to increase wheat production and the use of cover crops and regenerative practices in wheat. So if any producers are needing any kind of assistance with that, and are just starting out, or maybe they're moving along and are struggling, my contact information is on my slide. So I'll go ahead and share that, and we'll get started. Okay. Can you see my slide with the worm?
Yes.
Okay. All right. So Joanna and Jennifer asked me to talk about nutrient cycling and using a soil health management system and how that kind of plays out. They had a better title and I forgot what it was. So it's called nutrient cycling within a soil health management system. And there is my contact information. If anybody needs any assistance, I'm free and willing, and free is the key word there, especially for a KCD standpoint, and willing to help folks out. So let's just move into this. All right, so as long as our tools involved wood in our hands and our horsepower was supplied by horses or oxen, then we pretty much had to work with nature. And that's kind of been the case, for thousands of years, tens of thousands of years, as depicted in this photo here. And as we moved on, we started using horsepower, and the implementation of the plow, became part of the system. But as soon as we transitioned to this newer type of management, this mechanization, be changed from having wood and a dibble bar, planning with that, to having a steering wheel and push buttons. Our power was supplied by hundreds of horses packed into a diesel engine. Then our natural drive, our working with nature, kind of changed at that point and became more of a dominance of nature. And so we didn't have to work with it as much as we used to. And so that led us to managing principles and we used, started with the Green Revolution. We found that we could use massive amounts of nutrients to change the way we were doing things, from transitioning where we had the animals as part of the system and seeding down an area and grazing those animals, and then taking that out of production, and that natural mineralization of the nutrients from the working of the soil and the manure and the urine from the animals living on that quarter section, if it was in a quarter section, provided some of that stimulus there to the plants as we started to planting them. In 1837, the plow was invented, and that's right around when the Midwest and the Great Plains were starting to be settled. And that soil was completely different than what we had out in the east part of the United States that was developed under a tree regime. This is, huge biomass from prairies. So those moloch soils had a lot of inherent natural organic matter. And as we started moving to the system of plowing and regular tillage, we started to beat that carbon out of that soil. And that led to this downward, what we call this downward spiral of soil degradation. There are soil there where, it led to these consequences of change in our soil resources. We started to having increased tillage, and there was less cover on the surface. And as a result, a lot less biodiversity out there. Because we didn't have that lay period where we were seeding something down for a period of time. And also with the impetus of, the farm bills and whatnot, we started changing to whatever the driver was of that farm bill. And so that simplified cropping system really put a whammy on our soil organic matter. We started seeing erosion increasing, and compaction started to be more of an issue. That directly led from that decreased aggregate stability and resulted in increased soil crusting and even more compaction as the tillage continues. Finally, infiltration started to go down. Water would leave the land and would take soil with it as it was leaving, and along with that soil, our nutrients were leaving. So we were seeing eutrophication in a lot of our ponds and streams as a result of the soil with tide nutrients to it, leaving that area. Even in the case of out in the west with wind erosion, we are seeing with the working of the ground that decrease in aggregate stability. Organic matter is starting to blow away with those winds being as light as it is. Along with nutrients in our topsoil leaving and moving to those northern states during those critical erosion periods during the year. Ponding and storage, water storage, are, the water storage, of course, is going down because of the decreased infiltration, because of the loss of aggregate stability. You can see how this starts to compound. And then we get water sitting on the field. And it changes the state of that water, of those nutrients within that water to become anaerobic. And so then we are looking at less nutrient availability, there's more gas off, and as a result, more increased disease. And when you move to some of these older countries where, where tillage has been a pretty big part of the entire system, that decrease in crop yields, and then of course eventually the increase in hunger and malnutrition, which they call hidden hunger, where you're needing more calories. And so, the processing of food, of course, results in hiding these calories in this processed food instead of our natural foods with the low nutrient amounts in them, as a result of this downward spiral. This linearization of agriculture, if you've not read this book by, oh, I just lost his name. Oh, someone can type it in the chat if they remember it. But the book that this came from was really pretty telling. It kind of fit pretty easily with that schematic that we saw earlier, but you can see initially the energy that we get from the sun is what, grows these plants, but then we start harvesting this fossilized energy from the ground initially in the form of fertilizer, that was stored deep in the soil profile for, millennia, multi-millennia. And we harvested that, brought it up to the surface, and then put it into the soil itself and planted seeds. Then we utilize even more fossilized energy, but from the production of pesticides, and add a little water. And eventually we use some more fossilized energy in the way of gas or diesel throughout this process to harvest. And then eventually that grain that is taken from the field is removed, and it leaves that system. It's not fed at that local level like it was, in the early 1800s. It was sold and processed into food stuff that was then sent into a city or a urban area where, of course, it was eaten, and then the process of human nature itself, defecating out that nutrient from that fossilized energy, then is stored essentially into lagoons. And if we have an issue with those lagoons running over or whatnot, they can eventually end into the sea. But that shows that it was Darren Qualman. I just thought of the name, Civilization Critical. I always do that after the fact. I end up remembering stuff. But Darren Qualman's book goes into great detail about how we have changed the landscape from the way we used to do things to this linearization of agriculture, and how we're no longer cyclical. And those cycles are important, especially in the case of nutrient cycling. So these ecosystem processes, if you've not read this book by Alan Savory and Jody Butterfield, the holistic management book, and even really the older versions actually go into even greater detail of these ecosystem processes and how the water cycle, the energy flow, and the mineral cycle, and these community dynamics are tied together in this total overall system. So when we look at those different processes, what does that involve? Well, the one that I mentioned, the water cycle is a big part of what helps us with oh, sorry, my I took a slide from my deal that is actually has very important for life, obviously some overview on it. So the water cycle itself is, let me see if I can stop that from doing that. Take off that that little bit of I didn't realize that had that on it. Sorry about that. I'm just going to share it right now on my screen. Can you see my screen now with just the water cycle itself?
We're
Anyone?
we're seeing it,
Okay.
but in like your presentation mode.
Yeah, that's
we can
okay,
still see
because for some reason I got a recorded slide that I had recorded previously. I guess I could have just left it played and I could have just taken a break, but the water cycle is a pretty important part of these ecosystem processes, and one that I just recently watched this and I posted it in the Kansas Nebraska stewardship page by this, I think her name was Dr. Claire, and I can't remember her last name, but she went into pretty great detail on what it takes for rainfall to occur. And that it's directly derived from this water cycle, where you can see up here in this upper atmosphere, from the result of transpiration of plants provides that aerosol, and then the biology that's within the atmosphere, along with, even small sediments from wind erosion and whatnot, creates the heaviness of that rain. And as it cools and goes up and down, then we end up with this rainfall impact. And we don't have a lot of control over that, we think, but we actually do, because we've changed the local the landscape, so much that we don't have as much cover, we have less transpiration, and we have less infiltration and groundwater storage. And so we tend to believe that our only impact is located in this yellow circle itself, which shows, where if we can improve our soil health, we can get better infiltration, we can get better groundwater flow, and then we can improve it that way. But it first starts off with the plants. So that's pretty important. I'm going to go ahead and go back into the mode now, and I'll skip this slide, and I apologize for that. And like I mentioned, having that little bit there. So community dynamics, when we look at, how they impart what they do into our soil system, this quote kind of states to me exactly, what occurs out on the landscape. And what we need to remember, of course, when we're thinking about the soil microbial biomass, is through everything that all organic materials must pass, and also some inorganic materials when we're thinking about our fertilizers. But we always need to remember that microbes eat first. So the nutrient tie-up, is part of the system as well. And when we look at energy flow from these microbes themselves, energy is lost from one level. Up at the top here where it says energy flows, we have secondary consumers or carnivores that are feeding on our primary consumers or herbivores, and they're ultimately feeding on those producers or plants. And it goes right back to that soil food web again, where we look at, our driver of this entire system being rain, plants, and the sunlight itself, and then oxygen and CO2 being big parts of this. And that drives that nutrient cycle, nutrient cycle, as decomposers feed on one another. It's all about eating and being eaten. And like I said, energy is lost from one level to the next. Around 17% of the growth moves to the next level. 33% cellular respiration, and 50% waste. This is all lost as heat or energy that we can't use. And when we open this up and don't have those producers there, you can see how this nutrient cycling can be extremely broken. So how do we go about fixing it, of course, is by focusing on the principles. These are the principles that carbonize the soil ecosystem. So these 4 principles, and I'm still going back to just the 4, but there's more in here than just 4 principles. If you'll look at maximizing biodiversity, it's not just plants, it's plants and animals and biology itself. If we can increase that biodiversity, we can feed that soil life along with those maximizing the continuous living roots. And then we need to protect them with the minimizing the disturbance and maximizing the soil cover. So, like I said, it's all about feeding and protecting the soil biology. Soil organisms are driving the benefits obtained through achieving and improving the condition of the 4 principles. Therefore, the principles can be viewed from the perspective of feeding diverse continuous inputs of carbon resources or energy. The feeding benefits to the soil community arise predominantly from roots and diversity of roots and animals. And then we need to protect the habitat aggregates where they live in those storehouses that they've created in organic matter. That protecting benefits to the soil community arise predominantly from disturbance and cover. Maintaining soil organic matter and aggregates reduce runoff and risk from erosion. They help buffer the temperature when we can protect them. They like to survive in the same type of temperatures that we do. And also reducing evaporation, because this is an aquatic environment that this biology lives in, and that allows us to feed, our plants that we're trying to derive yield from eventually. The feeding also helps break disease cycles. It stimulates that biological diversity. Different root types, call out to different types of biology. There's a lot of research on that. It helps increase organic matter and then nutrient cycling as they're eating and being eaten. Of course, they're excreting out nutrients. And that helps and enhance plant growth and increases our predator-prey relationships, ultimately as the pinnacle of this kind of triangle of feeding. Here's the different aspects of the feeding. You can see the stimulating below ground biodiversity, breaking pest cycles, which is pretty important. That increasing ultimately the predator pollination habitat as well, which are in decline, obviously. There's some new research out showing that we're losing even more and more insect diversity. So protection, ultimately maintaining stable aggregates. They do turn over. Johann 6 has some an older paper that was written showing that every 6 weeks these aggregates can turn over. But inside and along these aggregate surfaces is where a lot of our organic matter is stored, and it's where the biology does most of its work. And those aggregates help us manage erosion. Allows that buffering of temperature, because we get oxygen down into those aggregates and within the soil profile. So it's less of a concrete thermal mass heating up. It has that oxygen in there that helps temper the temperature. It reduces evaporation, maintains soil organic matter, and increases water storage eventually. That's the ultimate goal, especially in the semi-arid West. And when we look at this paper, this was probably one of my favorite ones by Lori Drinkwater and Snap, that kind of goes into the way we've been doing things over a period of time, and how that's not completely working out really well for us. But this dominant management paradigm is what we do on the majority of our croplands. We apply a lot of nutrients to meet the needs for yield goals, and that's been indoctrinated into the system. But the problem is that it's pretty leaky. We don't have really good, nutrient cycling when we're just putting in a nutrient itself. So we load it heavily. You can tell by the width of that arrow on the front end. It goes into this soluble pool, and we hope that pool doesn't leave. And that the thought was that by mass flow, diffusion, and root intercept, that we're going to come into contact with this pool in some way, shape, or form, and it's going to feed the plant. Unfortunately, that pool is pretty large, and then it leads to leaching and runoff, and that's the downside of this, especially in some of the sands and in western Kansas, in south central Kansas, where they have a lot of nutrient issues in water, direct result of this soluble pool not staying in place and moving off. Then when we have the simplified cropping system, we end up with soils that are, especially if they're tilled, that are very anaerobic, and so we have some gas losses. Then we get a lot of P fixation from iron, magnesium, and calcium, and it's not very solubilized, so it doesn't stay in that pool. It gets tied up, and then it's also tied to our soil colloids. And when we get a rainfall event, if we don't have good cover out there, then we lose that to the atmosphere. And our plant and animal residues, you can see by the width of this arrow, is really quite small. So we're not getting a lot of diversity. We don't have living roots throughout the years. We don't have good cover. We don't have good biological communities. So that depletes that organic matter, and our soil life becomes fairly simplified in a bacterially dominated type of system. And so that leads to less nitrogen and P mineralization. So when we have less mineralization, then we have this pool that's sitting there and is subject to a lot of issues. So you can see this photo, kind of indicative of this kind of system. We have fallow periods, 4 to 8 months, and in some places, even in the West, longer than that, up to 13 months, that doesn't provide anything to the soil system. And when we look in perennial systems like a pecan system or an orchard, there's bare floors. They say in order to harvest efficiently, they need that bare floor, but it's also very limiting for soil life. We have since then, NRCS has been a really big proponent of the 4R nutrient strategy, and they've reboxed it, took it out of its whole package, and now they call it smart nutrient management, which is really just, again, the 4R strategy, which is the right source, the right rate, the right time, the right placement of nutrients. So we're doing less nutrient application when the goal is to do less nutrient application when there's not a living plant out there. So less fall or summer applications before, in the case of wheat, before we have any wheat growing out there. Several methods also are being incorporated in this, which is side dressing, banding, split application, in order to decrease the amount of surface application that would be subject to loss. So that's supposed to increase that fertilizer efficiency, but this is just tweaking that nutrient paradigm. It's not really changing it in any way, shape, or form at all. I mean, the amount that we're putting on now could be, from our previous slide, is a little bit less, and it's still going in that pool. And putting it on at the right time does increase your nitrogen efficiency, but phosphorus is not impacted much. We still get loss. We still have gaseous loss. We still get fixation. We have limited solubilization. We still don't have any increase in plants or other residues. And so we still have depleted soil organic matter life, and we have less mineralization. So that's the crux of this whole system, is that despite the 30 years of effort, fertilizer use efficiency is still only about 50%. So for every pound you're putting on, a half a pound is either tied up or lost to the atmosphere, which is, a resource concern in itself. We still have the problem with the fallow land. We still have bare floors. And eventually, we get a lot more erosion from the system. There's that 40 to 60% efficiency. I just split the difference there with the 50%, but it's not as efficient as we are being led to believe that it is. And it's not a water quality management strategy in any way, shape, or form. Soil improving the soil and soil health management systems are the way to reduce water quality issues at hand. So this chemical paradigm, this change in our systems has been the loss of organic matter, so fertilizers don't work as efficiently as they used to. And after 30 years or more of concentrated effort, inputs consistently exceed our harvested out exports by 40 to 60%, according to Bolin and Gilks. David and Gentry, 1998 and 2000, Galloway and Cowling. I mean, there's a lot of research. Ready and Ready even have some as well, showing that our what we're taking off is lost essentially around 40 to 60% in this Gulf Stream area here, adjacent to where the streams and the rivers are coming out, that hypoxic zone. So how do we go about my clicker was really not working there. So how do we feed the world while reducing this nitrogen pollution? This is a paper by Zia and Yan, and they are talking about that exact same thing that we just showed you there. And this is a more even recent paper showing that nitrogen use efficiency is around 40%. And to make matters worse, it says nitrogen fertilizers has increased continuously during the last few decades, yet yields of these crops are not increasing. They're reaching a plateau that something is going to need to be done to the plant in a conventional system, to the plant itself, to improve nitrogen use efficiency, or they need to do something managerially, which would be obviously transitioning to a soil health management system. So we got to understand this compounding effect of what's happening when we're looking at soil degradation and this loss of nutrients. So we get the denitrification, we get anaerobic conditions, which cause these great losses up into the atmosphere. Here you can see we've got volatilization, and we also have denitrification, and that comes from those anaerobic conditions, and they can be from being waterlogged, and it can also come from compaction. And then we end up with leaching, where like it says, plenty of heat to convert ammonium to nitrate, and it leaves with the water. So it goes right down in those sandier soils into the groundwater supply, and it's basically gone. Unless you're using it for fertigation, then of course it's not gone. It's a usable component. But these different issues that we are seeing are the predominant scenario in most of our ag lands, and are actually becoming even more dominant because of they say because of herbicide resistant weeds. But if we look at a more ecological nutrient management approach and the holistic approach to nutrient management, we can get better yields. We can achieve better fertilizer use efficiency and reduce environmental pollution by changing the way that we add our nutrients. So the 4R strategy can still be applied here, obviously, but we need to start reducing the amount of inputs and diversify what we're putting out there by using cover crops, composts, even some of the newer things like the in-soil algae, adding biology, creating an environment for the biology to be active and a good participant is involving, of course, the principles by minimizing tillage and whatnot in our disturbances. And that can then change the way these pools are looking. So now we're really reducing the nitrogen and phosphorus fertilizer. That soluble pool becomes larger and more localized for the plant itself. We get a little less gaseous loss, but I mean, that can still happen. But now we're adding in more nutrients from plants and other residues. Our biology, we also have cover crops that can capture and catch anything from that soluble pool during that period that we saw previously, where we had the 4 to 8 months of inactive root growth. So it'll hold it. They also provide a little more of that juicy fruit type carbon that feeds that biology, that increases that mineralization. And then also we can get some tie up in some of the biology itself to keep it from leaving our soil system. And on top of that, we have enriched soil life that makes more of these mineral reserves of phosphorus more available, like the phosphate solubilizing microorganisms, the bacteria, actinomycetes, and fungi that can break those chemical bonds that are tying those soil colloids to that phosphorus with the way that they feed. The diverse inputs are a key to this system in order to reduce this fertilizer over time. And for a lot of people can be very problematic and will take, this doesn't happen in just 1 year. It can take multiple years. And of course, this is an aquatic system. And so the less water you have in your system, the longer this takes to happen. So in this approach, fertilizer application, the loss arrows are a little narrower, but the nutrient supply to the plant is greater because of the use of minimize the principles, essentially. Because we've used the principles now, we're getting better fertilizer efficiency, and that can be anywhere up to 80 to 90% in some instances. So this impact of building carbon, then by adding carbon to the system, by adding that biological life, is has a direct result on our organic matter. And so this is a pretty interesting paper that talks about that mineral associated organic matter and how modest fertilizer inputs on the left has a direct benefit to higher amounts of organic carbon and longer term carbon being available versus our high fertilizer mineral associated organic matter is bypassed, essentially, because the plant doesn't need that organic matter as a resource for food resources for the biology. So we need to you can see on the right, it says heavy fertilizer application, darker green gradient disrupts these plant microbe mineral interactions. And this is from this new mineral associated organic matter paradigm has come about over the last probably 4 or 5 years. And people are starting to look at it and research it even more to see how they can improve it. And the best way to improve it, of course, is by using the principles and adopting those and using them at the field level. What does that do from a plant root standpoint? In humans, you can think about biofilms. I mean, people wonder what exactly that is, but if you think of yourself, we have biofilms inside our guts, right? And it helps keep us fed because the biology that's in our gut captures some of those food nutrients and then pulls them into our system and uses us so that we can function on a day-to-day basis. One other human negative biofilm to think about is the biofilm that's on your teeth, plaque, which is full of bacteria. And if you don't brush and you continue to feed them high sugar, it can result in decay. By changing your diet, some people say, and this is just probably pure speculation, but it may be true, you can change and reverse decay in your mouth from changing your diet from plaque. But the microbial advantage of microbial biofilms within the soil results in these rhizosheaths that you see on the right. So once we start getting good root exudation, that can facilitate the exchange of nutrients. It enhances soil fertility. It solubilizes minerals, helps fix nitrogen and produce plant growth promoting substances, and reduces the need for synthetic fertilizers. It can help boost crop resilience and help plants withstand environmental stressors such as drought and heat, because you can see within that little biofilm there's a lot of moisture, and when it cakes around those roots, that becomes a really great environment for biology to live and that keeps that moist and keeps the heat down by improving the what am I trying to say? The soil aggregation that can be a result as the outside of that area. Helps control pests and diseases by producing antimicrobial compounds and triggers plant defense mechanisms from enzymes and terpenes. Helps reduce the reliance on chemical pesticides and fungicides and can improve water management and enhances soil water retention, reduces evaporation, and promotes efficient water use, making ag water more resilient. In sandy soils, these happen quite a little bit quicker than they do in clay type soils, just because of the nature of the soil itself and the environment. So that's something to be aware of in the southwest part of the state, that you can see these rhizome sheaths occur quickly if you start to follow the principles themselves. So here's why it works so well, is it's quorum sensing, or you can call it metabolic cooperation. This is a pretty simplified diagram of what's happening right there adjacent to the root. You can see we go from right on the edge of the root, and then it shows that fungal hyphae, and that hyphae itself, once plants' roots are colonized by them and they start to grow, where the soil bacterial community then will associate with the hyphae, and they can either form a monolayer or a multi-layer of a biofilm on the surface, consisting of all different kinds of bacteria and fungal spores and species themselves, and the plant microbe interactions that take place in mycorrhizal plants can further help increase mycorrhization and direct influence of the diversity of microbial population and its surroundings. So there's not only plant growth benefits as a consequence of this biofilm that's occurring, but there's also social interactions. There's benefits to the soil quality, as it improves nutrient cycling because they're eating and being eaten in that same area. Increased focus also should be on these multi-species biofilms, as they may produce a lot of different types of sugars, which help that soil cling and adhere to the soil, or to that root surface, and creates that nice environment where that biology can grow. So that's just a little bit more on the benefits of that biofilm and how the biology all works together. And once they're there together, can feed off of each other and provide a lot of nutrients to plants. So what happens if we don't allow this to occur, that biofilm and those rhizosheaths? Well, a lot of it happens because we over fertilize, and that causes a lot of disease, causing micro organisms to be in place, can cause diseases like take all, and a lot of our make them more susceptible to rusts, and a lot of those oospores become dominant in this over fertilized type of system. It increases that disease severity. Any little lesion that could happen along the plant root from, say, a midge feeding, then allows more spores to enter, and it causes more micro spore production, and eventually you end up with feeding across the entire field. And if you've ever listened to Tom Dykstra, he has a pretty good presentation, I know, on YouTube about this impact of over fertilization and what that involves across the landscape. But when we start to reduce that fertilizer, and we get that quorum sensing occurring along those biofilms themselves, from that reduction of that fertilizer, then it allows the biology to start providing those nutrients. So we end up with a lot healthier plant in the end. Ways we can do this, of course, is by minimizing disturbance. This is a little bit more on the principles themselves. That if we disturb that habitat we then start to limit the types of microbial communities that will be living out there. We destroy their housing essentially, in structure, and we end up with a lot of issues, especially when we look at excessive tillage, chemical overuse of fertilizers and pesticides, and biological, even overgrazing, and the fallow period is a big disturbance that can cause problems. So when we look at tillage management itself from even an organic situation, uh, it just depends on the frequency, the duration, and the intensity of that tillage. So some folks are saying, well, we can and maybe need to do some strategic type of tillage in order to control weeds, or maybe even in order to change something within the field. How often you do it, when you do it, during that time period. If you have living roots that'll come in directly after, can remove that impact, and the type of equipment that you're using to do it. The depth of that equipment, and the speed, and how heavy your disc is that you're using, uh, or a moldboard plow where you're doing total inversion, is that intensity. And all of those can have problems when we are looking at trying to control or reduce our disturbance. So why is cover so important? This is a photo that Neil Sass up in Iowa took at a four-way stop, and there was one field on your left there you could see that was actually no-till, and the other three fields and had been using cover crops. The other three fields were not in that system within Iowa, and you can see what's going on there. We've got increased erosion, decreased infiltration, a lot of evaporation occurring. We have soil temperatures that are really high in those disturbed areas versus the undisturbed. And when we can keep the cover there, we can increase our habitat for biology. We have better food, and overall, it's just a lot better environment for living beings as opposed to not living. So maximizing roots, we need to start growing more crops in the off season, eliminating the fallow period, or that some folks called it the recropping interval between corn and beans. It's still 8 months with absolute no carbon being, released, and not helping these rhizo sheets in any way, shape, or form. You can see these cover crops here have pretty good soil adhering to them. We need to increase maybe even our time in perennial crops if land is owned, which allows that perennial break like we used to back when we had actual animals in the system, and manage the rotations when we're grazing for our forage height a little bit better if we're thinking about rangeland in that aspect. So when we look at nutrient cycling as a whole, the carbon to nitrogen ratio is what everything is tied to. The more lignified, of course, the higher the carbon, the nitrogen ratio. As it becomes a little more greener, we start to lower that amount. And that's directly tied to this mineralization versus immobilization. When things are green and the biology can eat them, it'll create fertilizer. If it's not, and it's a little bit more tied up, then we have issues of where we have nutrient tie up. This is a pretty good picture from Brady and Weil, showing that nitrogen depression period, where we have a high carbon to nitrogen ratio residue or crop on the surface. The biology has to take some of that soluble nitrogen in that pool and then use it to break it down. And so it gets tied up in those bodies and doesn't get released until that is all converted over. Here, where we have more legumes in the system, you can see we can improve that pool. We have a larger amount of mineralization occurring as opposed to mobilization in the top. And it's all about how they feed. They need nitrogen and they need carbon for energy. So they need the nitrogen for protein in order to move and do things. So we need to start impacting our fields with a little bit more diversity in the cover crops. We need to put in cover crops that can build organic nitrogen, such as legumes. I know in Western Kansas is a little harder because of wind erosion. You'll be subject to that if you have too many legumes, because the residue turnover is extremely rapid. So you have to be very careful. But protein is necessary for regenerating soil biota and biology. So at some point, you need to try to add at least, 25 to 30% of the mix, especially following what needs to be in place when a cereal is going to be following that mix. Much of that soil N is gone after a prolonged saturation period, and legumes alone or in combination with grasses can provide soil biology a quick nitrogen fix, and it can also help restore those biological pools in the soil. And so having a six-way mix, as you're further along in the system is probably really good for someone that's more experienced, or just a simple OP mix. I don't believe this is oats and peas. This is brassicas and cereal rye. But for just starting the system to get it going is a good way to try to incorporate, the use of cover crops.
Hey, Candy.
Yep.
There is a question in the
Okay.
Q&A. I'll
Go for
let
it.
you take a look and see if that you want to answer it now, or we can come back to it at the end of the presentation as well.
Let me see if I can even see it. I'm trying to find the screen.
Ah,
I can't find the screen. You want to just read it?
sure can. It says, I'm quite new to understanding soil. I'm a non-resident landowner. Please explain to me the difference between fallow and decreased tillage. My farmer has suggested a fallow period, saying it is good for the land to rest.
Ah, yes. That's the it's actually the fallow period has nothing to do with rest or even you know really it started out, if you go back, as kind of a mineralization program. So once they put the fat, had the weed out there, they would allow it to sit and you go in and then you would plow it, you would till it. That would stir up, add oxygen to the soil profile, and then the biology would start to feed, and it'd feed on that organic matter that was, actually left in the soil, using your that for a nitrogen resource. And if you had a plant come up, shortly thereafter, it would directly feed it. But then they found out, oh, look, we can get a little bit of water storage out of this. But the problem is, and Norm Clock, even here at K-State University, did some research on the fallow expectation, and it was only around 25% efficient. So when you think about you're getting what, if you get 10 inches rain, 25% of that is all that you're saving of that 10 inches of rain. It's not a lot, but it's also not a little. I mean, so for some people that are in that fallow system, it's been supported by universities, and it's also been supported by USDA from crop insurance, from a crop insurance standpoint, as a mechanism to try to improve our water profile. But it really actually doesn't. Roots themselves, and you saw on those biofilms, are creating moisture. You could see those small little droplets on the surface of those roots. They make a nice little water film that's on that soil surface. And as the plants go through photosynthesis, it makes more of that water available. And then the roots themselves, as they die back, because they do die back, especially if they're cover crop roots, even in perennial systems, 30% turnover. And wherever those pores were, where those roots were, those channels, they allow then more water infiltration and storage to occur. So saving that water can be a detriment over a period of time, because eventually you're starting to shift that microbial community from, you know, to a more bacterial dominated system. And the bacteria thrive on fertilizer, and fallow thrives on fertilizer. So then you just kind of are snowballing into this system of where you're having to add more inputs. Some of the folks on the Soil Health Alliance board call it the moron approach. Eventually, you're gonna have to keep putting more on. In order to maintain that fallow, you're gonna have to use more herbicides. I mean, because you've got 3 to 4 months there prior to planting wheat that you have to maintain no living roots. So that requires fertilizer, or it requires steel, where you're gonna have to be doing tillage. That tillage destruction is an obvious biological, you know, turnover immediately. The herbicide, of course, you're not providing any living roots, so we start to get aggregate breakdown right there at the surface. And it's just really up to you what your ultimate goal is of your system. And if it's to, you know, if that's the system you're used to using and you want to try to keep going that way, then by all means, don't remove the fallow. But if you're thinking and you'd like to be a little bit more natural, and you try to want to eliminate that, because there's nothing that says you can't. We have producers all over in the western part of Kansas, most all of them on the board that are in the western part of the states, and even two of our employees, Joanna and Jennifer, both their husbands are farmers, and they've eliminated fallow. So that it's something that you really need to talk to with your farmer that you've got as your renter, and see if that is a goal that they'd be interested in doing. And maybe take them to one of the Kansas Soil Health Alliance, you know, field days, or go to the school that Jennifer and Joanna are going to have in Buckland this summer, and she can tell you the date at the end, to learn a little bit more about how these producers are doing this. And eventually, if that is your goal, that you want to try to be more ecologically minded, you may have to eliminate that producer. Just saying. I know that's a harsh thing to say, but if they're not in in the same car with you, going down the same path, you know, and they're driving a different direction, you're not going to get the result that you want. And ultimately, I feel like it's your land, and if that's what you want to do, then by all means, learn more and make a change. But the soil itself did not evolve under bare conditions. There's no fallow in nature. If there is, it's a ecological disaster. And then of course we get early succession to happen, where we bring in, you know, the plant, those annual weeds essentially, to cover the soil surface as soon as possible, so that eventually we get a change in the dynamic there to a perennial system in nature, whatever that may be, whether it be trees or grass plants. Here in Kansas, it's grass plants. So we know that it's possible to do it. It's just going about how to do that. And these schools can help you get that figured out. So plug away for the Alliance, so to speak. And out west, having animals, it's not totally 100% necessary, but I'd say it's critical in order to achieve a full soil health management system. After wheat, it's a great time to put in a cover crop if you want to transition away from fallow, and graze them, like you see this little sheep here in this sorghum. Feeding on that cover crop improves the biodiversity. We can add in some legumes to add a little bit more nitrogen. The poop from these animals feed and will be in the profile as organic nitrogen, and be available later on when you go to plant your commodity crop. But integrating livestock and grazing cover crops is critical, I think, especially in the semi-arid West. And we know that increasing time in diverse perennial crops is pretty difficult to do, but there are a few people there's a guy in central Kansas who's in Jennifer, he's in your group, and I forgot his name, but I can see him, and that's my problem, my Alzheimer's that I have. But he does perennials in rotation. So there's some folks in Western Kansas that are actually even doing that. So for some, not likely, but for some, a possibility. And increasing compost and sources of carbon. Some folks are saying out in Western Kansas, biochar is, and there's some on our board that are using it in furrow to try to build the structure for the biology to survive because they're so low in organic matter. They had to do something. That can be a boon to the system as well. Growing living roots throughout the year increases activity, increases plant nutrients. All of these are increasing or improving. You can see every little bit of it, and along that root surface, all of the bacteria. And there's even more to learn about how roots can feed on bacteria by Dr. James White and his rhizophagy process. It's another way plants can get nutrients. Algae is another way, that plants can achieve. Eventually, your journey will, if you start a soil health management system, your journey will lead you to these higher level management systems that lead to more mineral associated organic matter and decreased inputs. And as you're learning, of course, in the adaptive management scenario, the fine tuning is the process of the learning. So as you're getting some new information and plan with your either your renter or even your family, I think it's important to include your family in your thought processes on how you're doing things on your land. And then implement it at a small scale first, just to see if it's going to work and monitor it. And then if it didn't work, what do you need to do? This is that adaptive part to change that at the local level. Maybe it won't work at all, period, and I'll never do it again. Or next time I'll change this, that, or the other and evaluate it. Because that then leads you again further on to doing something better and different and completely evolving. We're not meant to sit and rest. We're humans that are meant to be moving and thinking and doing, and if you rest, you rust, so to speak. And this is from Dr. Hatfield, who I see is on here. This is probably one of the best things that he shared with Barry Fisher, my old coworker, was this soil aggradation climb, that as you start to see, start doing these soil health management systems, the biological activity is impacted really quickly. They respond, pretty well to that, but we don't know that that's occurring. As you can see, that noticeable change, we don't know that the biology is changing and that it's feeding, and that the organic matter turnover is changing within there in the soil until we start reducing, the amount of nutrients to notice that we get improved nutrient cycling. Where we really see the differences in the aggregate stability. We start seeing aggregates at the soil surface and around the roots. And then eventually, when you do start getting rainfalls, events like we've been having here in central Kansas, it's actually almost too much water. I'm not quite used to it. It's a little weird, the amount of rainfall we've been getting the last 3-4 days. Is it going in? Are you taking all that water in, or is it running off? And once you start seeing that change, then that you're well on your way to improving, your soil habitat for the biology. So we need to manage to carbonize the soil ecosystem. That's our most limiting resource, is soil carbon. That's the one thing that we don't have a lot of. And as we start doing, maximizing disturbance, it's getting even more limited. And that's starting to occur more and more in Western Kansas, just from the impact of herbicide resistant weeds. But that can be directly impacted by, keeping more cover on the ground. There's 3 stools to the disease triangle, 3 legs on the disease triangle. And same thing with the weed triangle as well. You gotta minimize light. We hope to maximize moisture. But if we can minimize one of those three stools, the light, the moisture, or the heat, if we can reduce the heat from the cover and the light from the cover, then we know we won't get germination. So that can help us eventually lead us into a better system for reducing these herbicide resistant weeds.
Hey, Candy.
All right, I'm done.
Never mind. Good. All right. Good timing. Are you able to see there's a little bit more in the Q&A? And
Yes.
then as well, everyone, you can either type in questions, or if someone else has a question by hand, we'll go ahead and keep the forum open. We had a 1 o'clock ending time, but we're able to keep this running. So if there's questions, and Candy, do you have time to stay on
Yeah.
for just a little bit? For
Yeah,
me?
remember, I have nothing to do.
I
I'm
wanted to double check.
retired. It's like I don't have a job anymore. This is my job, which is a really great job, actually. I'm kind of pretty pleased with the fact that I'm no longer an NRCS employee. I didn't think I was, but I'm pretty happy right now. So Kathy, I see you and bluntness. Oh my goodness. Yeah, that's me in a nutshell. Sorry about that. But if you have any other further questions, or you just want to talk, oh, I don't have, let me see if I can I could try to share my contact information. Feel free to, there we go. Is that shared?
I don't see it, but we can send
Oh,
a
wait, I
follow-up.
gotta hit the button. There we
Oh,
go.
there we go.
There it is. Now I pulled the questions on top. Feel free to call me or even email me, if you want to talk about this further. About and if you even want to do a farm visit, I mean, I'm more than willing to come and meet with you and your producer, since I'm allowed to now, and talk with you both about, what's needed, to try to meet your needs and their needs. Some people just don't really understand, what fallow is and what it does, and that they can still improve their system by essentially eliminating it. It's not going to improve their pocketbook a whole lot, because that summer fallow practice money is pretty good. Oh, Kabir. In a study at the University of California, Davis showed that up to 70% of rainwater running off from fallow field compared to a maximum of 10% running off in cover crop fields in the rainfall event. Yeah, so what Kabir there, and I worked with Kabir, we've worked together for a lot of years, and he's in probably one of the most degraded places in the United States, in California, where they're growing all of our food that we eat. That is a really good, even more ammunition for the fact that we are having problems with the fallow, and the fact that it wasn't really meant to be a water storage savings apparatus. Is our windmill grass a sign that we don't have enough cover residue, or is it a sign of a mineral imbalance, or both? And what test should I run to find the mineral imbalance? From Roger Heyer. Okay, Roger. So Bryce and I have cussed and discussed windmill grass at length, ad nauseum, in fact. I would say, I'm sure he's not done with discussing it, but we are both maybe in two different camps. He wants to try to control it with tillage, just to try to break up, that connection that it has with the soil there from the root, and then by getting something in to take over that area. And so you are right, it is a problem with cover. And when you look at where you have it, and if you want to, Roger, you can come off of mute and actually talk. But I think most people, and from where I've seen windmill grass, it's creeping in on the perimeter. So chloris is an early successional grass, not really palatable to any animal, but the reason why it's there is to try to heal. And so it can be a mineral imbalance, but I think it's more of a trying to fix the compaction and the issues that are occurring there. Just like a lot of people always want to try to put in plantains in their mix, And plantains love compaction and they grow well where there's major disturbance. Hence the reason why, like in Iowa, our roadsides are completely covered in that beautiful, not plantains, the other one with the purple flower that I can't think of the name of that looks like a plantain. Plantains also like compaction as well. But I lost the name of that plant. But these plants grow where there's disturbance and where there's compaction, and they won't grow in pasture where you have low disturbance and low cover. We can't get them to survive by trying to put them out there. And people are selling them, but they only grow in our gateway. And so when you look at windmill grass, you'll see it along the perimeter where you have your turn rows. I've been this is just me, and you can follow Bryce's suggestion of going in and trying to run a V-blade through there and getting a cover in immediately after. Or I think what we really need to do is to put some field borders on a lot of our areas. There's cost share money available. Put in a pollinator. Doesn't have to be no more than 15 feet wide, but that'd stop the chloris from creeping, from that grass edge into the field. I know you're like, well, that's reducing the amount of usable cropland acres that I have in my field, but it's also increasing biodiversity in your field. Jonathan Lundgren has got a lot of research showing the benefits of having pollinator habitat adjacent to fields. Even Iowa State and their prairie strips have shown some benefits, from a disease and insect feeding standpoint, that they've seen reduction in both. Just having the biology adjacent, to that perennial area can improve it as well. But other than that, there's nothing really, we looked at herbicide wise, there's not anything really too whoopee that is rated to do away with, windmill grass from that standpoint. So you can try to graze it and graze it early, but I know Nick Voss has said it doesn't work right for his sheep. Maybe goats is an option, and I don't know if goats will even eat it. I know goats will eat Sericea lespedeza, because we've had used goats to do away with some of that in a very, very small area, and they did a good job of annihilating it. But you could run a mineral test to see, and then go to that book what's his name? He wrote the book on the mineral nutrients that are, I don't know if chloris is in the book. I'll look it up and I'll send it to you to see if in that weed book if chloris is in there, the windmill grass chloris, and what kind of a mineral nutrient deficiency it involves. But the best.
Can
Go
you hear
ahead.
me?
Yeah, I can hear you.
I was listening to a podcast with John Kemp. That's the reason I asked about the minerals.
Yes.
He was talking, it was about mustard, and they run a calcium test or something like that because the barley or whatever they were trying to grow wasn't doing very well, but the mustard was thriving. So they did a soil sample and they had adequate, I don't remember which ratios they were talking about, but
The calcium to magnesium ratio, is that what you're talking about?
probably, yeah. And then they ran I don't know if they did a sap analysis or did a tissue test, and then the mustard was like taking up like 10 times what the barley was.
Wow, that's
And
wild.
it was something like that. And it's like, well, that got me thinking, say, okay, is this windmill grass taking up something that we have too much of? Because I have a field, it's more than just the field borders now. It's basically
creeping.
through the whole field.
Yeah.
And we tried to drill, or we planted rye in it this spring, and well, that didn't work because the rye took too long to get up and get going. So we have
dry.
just as much windmill. Well, no, we had decent
You had moisture? Oh,
but the rye just didn't outcompete it.
yeah. And there, and I hate to say it, you know, we talk about minimizing disturbance, but maybe it ought to be strategizing disturbance. And I know Willie Durham, my counterpart, is big on this, especially from a grazing standpoint. But sometimes I think strategic disturbance in a system can have a beneficial impact as well. And maybe what Bryce is talking about, you know, going out, V-blading it and getting oats in, you know, like either putting a Gandy box on the back and blowing them out on the surface. If you're gonna have a rain, you know, it's coming, which is very rare out there. But or just running a drill behind it, you know, and getting the oats in immediately after to see if you can get to, you know, early spring, if you can get them going ahead of it after you've cut it. But the problem is the roots on that stuff. That stuff is just, it's nasty. You are right.
Yeah.
It'd be interesting to take some of it. And if, I mean, the leaf is nothing, like next to nothing.
Right.
But wouldn't it be cool to try to get some of it and then get a plant sap analysis off of it to see what's in it? Or a plant tissue test even to see what's in it.
Yeah, I was
I mean,
considering
it'd be
that.
costly, but it'd be interesting to try. Maybe we could try it through this KCD stuff that we got for wheat, because that's a big wheat inhibitor right there. I
Yeah.
mean, we'll try, maybe we can try it. I'll talk to Dan and see how much money I've got in that pot, you know, for trying out weird stuff. And maybe we can get some of that windmill grass and we'll see what's actually in it that's causing the problem. If
So
Kabir
if
or I know Marlon, I saw you were on here. If you guys have any suggestions, you know, type them in the chat or come off mute and provide those as well, because those guys are smarter than I am.
Mhm. So, all righty, thank you.
Yep. Sorry I couldn't help you.
No.
But maybe we can look and see what's in it. I'm interested. I think that'd be pretty neat to try out. Either on you or Bryce, or maybe both of you will turn it in and see what's in that plant and what's missing in the soil. Maybe we can figure it out. All right, I think I covered them in the questions or the open-ended comments in the chat, Jennifer.
Yep, I'm seeing that too. Are there any other? Just raise your hand and I can make it so I can unmute you or allow you to unmute yourself if someone else has a question. I'll give just a second to see if anyone does, and if not, we'll wrap things up.
Well, I appreciate you inviting me to do this. I probably maybe could have done a even better job, you know, and added more, but you can only talk for so long, right? And trying to keep it in a soil health management system is not the easiest thing to do. But if anybody has any questions or what have you, you know, feel free to give me a call or shoot me an email. And if you want to do a field visit after next week on the 2nd, I'm available to go anywhere in Kansas, you know, to take a look at some things and kind of try to figure out some ways of improving our soil on producers' farms. And don't
Well,
forget to say the school dates for Kathy, if you don't mind, Jennifer.
Sure. So it's August 1st and 2nd. We'll be in the Buckland and Greensburg area. And we'll also be doing something August 21st and 22nd in Jewell and Mitchell counties. And keep watching the calendar because we have several more events that are coming up, lots of them in August and September. If you are not receiving our newsletters, you can go to our website and send just contact us and I can get you added to the newsletter list. We're working on getting a button on the website to sign up for it, but that's a good way to keep track, or our social media pages as well. And I want to thank Candy for joining us. I know many of us have seen her in field, but not so much behind the PowerPoint, given the presentation from this viewpoint. And it was really nice and I appreciate it. And I'm going to real quick hand it to Joanna to give us a little update. I think we have our next month's speaker lined up, but at least we can remind you of the date and time for next month.
Yeah, so next month will be June 26th is when the next webinar is. And we are hoping to have one of our board members, Bill Bussing, on, and he is going to be talking about his relationship with the Tuttle Creek watershed. So we will see what he has in store for us.
Thanks so much, and thanks everyone for joining. We'll be putting the recording of this out on several different ways, so be watching for it if you want to go back and look again. Thank you.